The excitement was palpable in the atmosphere of the Interstellar Academy's largest auditorium, where students from across the galaxy gathered, their myriad forms casting an array of shadows on the walls. The Academy, a sprawling complex located at the nexus of several wormholes, was a beacon of learning and cooperation for the known universe. Today, it was hosting its most anticipated lecture series of the year, Understanding Lesser-Known Planets. The series was to begin with Earth, a planet that had recently gained fame or notoriety, depending on whom you asked. The title of the lecture, Why Earth is Called a Deathworld, had piqued the curiosity of many young minds from civilizations both advanced and emerging. As the lights dimmed, Professor Lyria, a renowned xenobiologist from the aquatic planet Gliese, took the stage. Her shimmering form, reminiscent of Earth's cephalopods if they had evolved to walk on land and master quantum physics, adjusted the translator device at her side. "Welcome, esteemed students," Lyria began, her voice translating into hundreds of languages simultaneously. "Today we explore a planet that is as beautiful as it is deadly. Earth, as its inhabitants call it, is the third planet in the Sol system and is known for its diverse ecosystems and challenging living conditions." She clicked a device, and images of Earth's lush forests, vast deserts, and deep oceans filled the screen behind her. Murmurs of awe echoed through the hall. Earth looked harmless, even inviting through these images. "However," Lyria continued, "don't let its beauty deceive you. Earth's environment is one of the most hostile in the known galaxy. It is a world where the evolutionary arms race has produced a myriad of life forms, each more adapted and deadly than the last." The screen now showed images of Earth's wildlife: great white sharks, venomous snakes, and fierce big cats. The students gasped, and some recoiled. To many, these creatures were the stuff of nightmares. "Let's delve into the reasons behind Earth's fearsome reputation," Lyria said, enthusiasm in her voice. She began with the gravity of Earth, higher than average for inhabited worlds, making physical survival there a grueling task for the unadapted. She went on to discuss the climatic extremes, temperatures that could swing from blistering heat to bone-chilling cold within a single day, and weather patterns that could destroy settlements overnight with hurricanes and tornadoes. "But it's not just the environment," Lyria pointed out. "It's also the organisms themselves. Earth is one of the few planets where life has developed an immune system so aggressive it can attack its own cells mistakenly. This makes diseases on Earth particularly difficult to treat." As she elaborated on Earth's natural selection processes, highlighting how every creature had to be resilient or cunning to survive, the audience was riveted. Each student realized that what for Earthlings was daily life for others could be an extreme sport or a survival trial. Lyria then touched upon the cultural aspects of humanity. Humans, the dominant sentient species on Earth, have a history replete with conflict and cooperation. Their resilience and adaptability make them formidable beings. The lecture concluded with an open Q&A session, where students eagerly asked about the possibility of visiting Earth, the protocols for interaction with Earth's diverse life forms, and how Earth's lessons could apply to their own worlds. As the students filed out, buzzing with new knowledge and a renewed respect for the precariousness of life on Earth, they couldn't help but feel a mix of dread and fascination towards this death world, a planet so dangerous, it was compelling. In this introduction to Earth, they had learned not just about its perils, but also about the unyielding spirit of its life forms, particularly humans. For many, this lecture had sparked a desire to learn more, to understand deeper, perhaps even to visit. But for now, they had to digest this new understanding of Earth, a planet beautiful and brutal in equal measure. In the wake of Professor Lyria's lecture, the Academy organized a follow-up seminar meant to delve deeper into the practical aspects of Earth's environment. The session, led by Dr. Varnock, a seasoned exobiologist from the arid world of Sarnath, focused on survival strategies in Earth-like conditions. His expertise in extreme planetary ecosystems made him an ideal educator for this complex subject. In a laboratory designed to simulate Earth's diverse biomes, Dr. Varnock began the seminar with a focus on Earth's aquatic environments. "Water covers over 70% of Earth's surface," he explained, adjusting the settings to mimic the deep blue of the Pacific Ocean. The beings here have adapted to extreme pressures and scarce light. Survival in such conditions requires specialized physiological traits. As the simulation tank filled, replicas of Earth's marine creatures appeared, from the giant squid to the nimble dolphins. Each student received a virtual interface to interact with the biomes, analyzing the adaptive features of these creatures. The lesson emphasized bioengineering and genetic adaptation, key areas of interest for students from water-scarce planets. Transitioning from the aquatic to the terrestrial, Dr. Varnock adjusted the environment to simulate the Amazon rainforest. Humidity filled the lab, and sounds of tropical birds rang through the speakers. In contrast to the oceans, terrestrial environments such as this are teeming with both flora and fauna. The diversity is staggering and the competition fierce. He guided the students through a virtual exploration, pointing out the symbiotic relationships between species, like that between flowering plants and their pollinators. The lesson here was on ecological balance and the role of keystone species in maintaining the health of an ecosystem. "Now let's turn up the challenge," Dr. Varnock announced, changing the simulation to the Sahara Desert at midday. The temperature in the room soared and the humidity dropped, mimicking the arid conditions. "Survival here depends on conservation of resources," he lectured, as they examined the adaptations of desert organisms like the camel and the fennec fox, known for their water-conserving traits. The students were tasked with designing an organism capable of thriving in the harsh desert environment using a genetic toolkit provided in the seminar. This exercise tested their understanding of adaptive traits and resource management, crucial for anyone studying terraforming or planet rehabilitation. Finally, Dr. Varnock introduced Earth's polar regions, adjusting the temperature to near freezing. These regions, though hostile, are critical for understanding global climate dynamics, he explained. The students studied the insulation properties of animals like polar bears and penguins and discussed the impact of Earth's climate cycles on global biodiversity. The seminar concluded with a group project where students had to propose a hypothetical research mission to Earth, outlining objectives, needed resources, and potential challenges. They used virtual reality to craft detailed environments and scenarios, drawing on everything they had learned about Earth's extreme conditions. Through these immersive experiences, the students gained not only a deeper appreciation of Earth's daunting environments, but also practical insights into how Earth's life forms had mastered the art of survival. Dr. Varnock's seminar was an intense introduction to the real-world applications of their theoretical knowledge, bridging the gap between alien curiosity and academic rigor. The next segment of the series, orchestrated by Dr. Alara, shifted focus from environmental adaptation to technological ingenuity. Dr. Alara, a roboticist from the technologically advanced Cygnus colony, introduced the students to the various tools and technologies developed by humans to survive and thrive on Earth. In the technology lab, filled with holographic displays and interactive modules, Dr. Alara began with the basics, tools made from the simplest materials. Humans were once primitive by universal standards, relying on stone, bone, and wood to make their tools. These were used for hunting, building, and crafting, essential for survival in Earth's early harsh conditions. She displayed replicas of early human tools, allowing the students to handle them through augmented reality interfaces. They simulated flint knapping and wood carving, experiencing firsthand how early humans shaped their environment with rudimentary tools. Moving forward in time, the focus shifted to more complex mechanical devices, like the wheel, the lever, and the pulley. These simple machines laid the groundwork for human civilization's advances, Dr. Alara explained. She detailed their evolution into complex constructions such as water mills and early engines. The seminar then explored the role of metallurgy in advancing human technology. The discovery of smelting changed everything, Dr. Alara pointed out, as simulations of iron forging and steel production ran on the screens. The students observed the transformation of raw materials into tools, weapons, and structures that allowed humans to expand into new territories and environments. Dr. Alara then introduced the concept of energy harnessing, critical to human progress. The lab's environment mimicked the setup of early coal-powered factories, progressing to modern renewable energy solutions like solar panels and wind turbines. Humans have learned to extract energy from their environment in numerous ways, crucial for sustaining their civilization in the face of various ecological challenges, she noted. The session delved into the digital age, highlighting the leap from mechanical systems to electronics and computers. Dr. Alara demonstrated early computers and discussed their evolution into the global internet, connecting the world in ways that were previously unimaginable. This digital revolution has been pivotal in managing Earth's resources and solving complex global issues, she emphasized. Interactive workshops followed, where students used Earth-inspired tech to solve hypothetical problems on their planets. They designed water purification systems based on reverse osmosis, energy-efficient homes using passive solar designs, and waste management systems mimicking Earth's recycling techniques. The segment concluded with a collaborative task where students formed teams to develop a prototype device that could be used in their homeworld environments, utilizing Earth technology principles. They brainstormed, sketched, and created models, using virtual reality tools to test and refine their designs. Through these practical exercises, the students not only admired the resourcefulness of Earth's inhabitants, but also learned to appreciate the universal applicability of the technologies developed under such diverse and demanding conditions. Dr. Ilara's session reinforced the idea that technology, born of necessity, could be adapted and applied universally, fostering a deeper understanding and respect for Earth's technological achievements. Following the exploration of Earth's technological adaptations, the next seminar shifted to perhaps the most intricate aspect of Earth, its cultures. Led by Dr. Hesh, a cultural anthropologist from the lush communal world of Bithara, the session was designed to delve into the rich tapestry of human societies, their arts, languages, and rituals. Dr. Hesh opened the seminar in a room adorned with holographic representations of Earth's cultural landmarks: the Great Wall of China, the pyramids of Egypt, and the bustling markets of Marrakesh. Culture is the lens through which humans interpret their existence and environment, Dr. Hesh explained. It shapes their responses to the challenges they face and colors their achievements. The focus began with language, the cornerstone of human culture. Dr. Hesh introduced the concept of linguistic diversity on Earth, with thousands of languages spoken by its inhabitants. Each student was given a device to listen to and analyze different languages, exploring the phonetic, syntactic, and semantic complexities. This linguistic variety, Dr. Hesh pointed out, not only complicates communication but also enriches it, offering a multitude of perspectives and ways of problem-solving. The session included interactive exercises in translation and decryption, helping students understand the challenges and beauties of intercultural communication. Next, the seminar explored Earth's artistic expressions. Dr. Hesh guided the students through the evolution of art on Earth, from cave paintings to contemporary digital installations. The session was interactive, with students creating their own art using Earth-inspired techniques, painting, sculpture, and digital media. Art on Earth is not merely aesthetic, it serves as a narrative of survival, resilience, and identity, Dr. Hesh explained. Students were particularly fascinated by the role of art in social movements and its use as a form of resistance and commentary. The seminar then tackled religion and spirituality, aspects of Earth culture deeply intertwined with its inhabitants' daily lives and survival strategies. Dr. Hesh explained how Earth's harsh and unpredictable environment led to the development of diverse religious beliefs, each providing its adherents with comfort, community, and a framework for understanding the natural world. The class participated in virtual reality simulations of religious ceremonies and spiritual practices from various cultures around the world. This immersive experience highlighted how these practices influenced human behavior towards the environment, community, and conflict resolution. Lastly, Dr. Hesh discussed the global integration of Earth cultures in the modern era, facilitated by advances in travel and technology. This segment addressed both the benefits of cultural exchange and the challenges of cultural preservation in the face of globalization. Students worked in groups to create projects that addressed these cultural interactions, proposing initiatives that could help preserve cultural uniqueness while promoting global understanding and cooperation. The seminar on Earth's cultural complexity offered the students a profound appreciation of the planet's diverse societies. Through this exploration, they gained insights into the ways cultural practices can influence and be influenced by the physical environment, preparing them to better understand not just Earth but the broader tapestry of life in the universe. The seminar series progressed to a session focused on the political landscapes and diplomatic relations of Earth, led by Ambassador Threll, a distinguished diplomat from the governing council of the Andromeda Confederation. Threll's expertise in interstellar negotiations and his understanding of Earth's complex geopolitical framework made him uniquely qualified to guide the students through this multifaceted subject. In a room transformed into a virtual model of the United Nations, Threll began by explaining the concept of nation-states, a fundamental organizing principle on Earth. Unlike many unified planetary governments represented here, Earth is divided into over 200 sovereign states, each with its own government, policies, and interests. Threll then delved into the history of Earth's international relations, marked by both conflict and cooperation. He outlined major global conflicts and the subsequent emergence of international organizations aimed at promoting peace, security, and cooperation among nations. To navigate these complexities, Threll explained, diplomacy on Earth has evolved into a sophisticated art, combining negotiation, cultural understanding, and strategic alliances. The students were introduced to key diplomatic strategies through interactive simulations, where they role-played as Earth diplomats handling crises, negotiating treaties, and forging alliances. The impact of technology on diplomacy was a key point of discussion. Threll highlighted how digital communication and real-time global news had transformed diplomatic practices, making them more immediate but also more public and scrutinized. The digital age has introduced new dimensions to diplomacy, including cybersecurity and information warfare, which are now integral parts of geopolitical strategies. As part of the session, Threll organized a mock summit where students were divided into groups representing different Earth nations. Each group was tasked with addressing a global issue, such as climate change, terrorism, or economic recession, reflecting the real challenges Earth's leaders face. This exercise provided practical experience in balancing national interests with global priorities, a situation familiar to any diplomat. The discussion also covered the role of non-governmental organizations, NGOs, and transnational corporations, which play significant roles in Earth's diplomacy. These entities often operate across national borders and can influence both policy and public opinion. They are vital players in the diplomatic arena, sometimes aligning with governments and other times holding them to account. In concluding the session, Threll encouraged the students to consider the lessons from Earth's diplomatic efforts in their future careers. Whether they chose to be diplomats, policymakers, or advocates in their own planetary systems. The challenges faced by Earth provide valuable lessons in the necessity of cooperation in the face of global challenges, the importance of understanding cultural differences, and the complexities of managing diverse interests. This deep dive into Earth's diplomatic practices offered students not only a glimpse into the planet's efforts to manage its internal and external affairs, but also broader insights into the nature of political power and international relations across different worlds. The final session of the series was designed not just to recap the extensive learning that had taken place, but also to integrate these lessons into a broader interstellar context. Dr. Celine, who specialized in intercultural relations at the Academy, led this reflective session. Her approach was holistic, aiming to synthesize the diverse aspects of Earth that had been explored in the previous sessions, and to foster a discussion on their implications for the wider galaxy. Dr. Celine began by revisiting the environmental themes from the first seminars. Earth's diverse ecosystems, ranging from deep oceans to vast deserts, have not only shaped the evolution of its life forms, but have also influenced human culture, technology, and politics, she explained. She mapped these environmental factors against Earth's technological advancements and cultural developments, illustrating the interconnectedness of these elements. Using a large interactive display, Dr. Celine showed how Earth's challenges led to innovations in technology that, in turn, affected social structures and political arrangements. Consider how the development of agricultural technologies allowed for city-states and eventually larger political units like nations, she pointed out. This discussion naturally led into the complexities of Earth's diplomatic interactions, as previously covered by Ambassador Threll. The session then focused on the concept of resilience, a recurring theme in the study of Earth. Humans have shown remarkable resilience in the face of environmental hardships, political conflicts, and cultural upheavals. This resilience is something that can inspire all species facing their own planetary challenges, Dr. Celine emphasized. She encouraged the students to think about how the strategies used on Earth could be adapted to their own worlds. To make these discussions more tangible, Dr. Celine facilitated a workshop where students could work in groups to develop potential exchange programs between Earth and their home planets. These programs focused on technology transfer, cultural exchange, and joint research initiatives, aiming to foster mutual understanding and benefit. In the latter part of the session, students were prompted to reflect on what they had learned about Earth and to consider their preconceived notions about the planet. Many expressed a newfound respect for Earth's complexity and the tenacity of its inhabitants. Others were intrigued by the idea of visiting Earth, to experience its cultural richness and ecological diversity firsthand. Dr. Celine concluded the session by emphasizing the importance of empathy and understanding in interstellar relations. The study of Earth teaches us more than just about one planet. It offers insights into the survival, adaptation, and progress that are possible under challenging circumstances. These lessons are universal, applicable to all beings, no matter where they come from. As the students left the auditorium, they carried with them not only a comprehensive understanding of Earth, but also valuable lessons on cooperation, innovation, and cultural diversity, lessons that would serve them well as future leaders, scientists, and diplomats in the interstellar community. The series had not only educated them about a distant Deathworld, but had also prepared them to engage more effectively with the myriad worlds of the galaxy.